Hey guys, so far with statistics, we've looked at dot plots, histograms, and now we're going to look at a different way to display data, and that's the box plot. You may have also heard of it as called a box and whisker plot. Those are the same thing, just two different names. So here is an example of a box plot. You'll notice that it has a box in the middle with a line through it, and then two lines that come out the side. Those are usually where that term whiskers comes from. What we can tell in a box plot is we can tell 5 different things from the data. We can tell whatever this number is would be the smallest number. That would be the minimum. The left side of the box is called Q1. Q is what I'm referring to as a quartile. We'll talk about that in a little bit, but that is separating the data into 4 parts. Quartile, quarter would mean 4. The line inside the box would be the median. And then the right-hand side of the box would be Q3, which is also called the third quartile. So that would be like breaking it into 3 quarters, which would be 75%. And then the line at the right-hand side would be the maximum. All right, so that's the basics of what a box plot looks like. So when we have data for a box plot, if we have an even set of data, obviously the median isn't an exact number, but it would be the number between the 2 middle numbers. And then same with quartile 1 and quartile 3. If we had an odd number of data, that data would be a little bit more explicit or specific for us to tell. So let's consider this data. So the one thing that I always encourage people to do with box plots is to list the data first from least to greatest. So let's do that. So we have 1, 2, 3, 4, 5, 6, 7, 8. I believe that's it. Let's see. Here, let me actually do that over here so we can 1, 2, 3, 4, 5, 6, 7, 8. Okay, the minimum data. So the smallest number in this data set is going to be 1. The biggest number, or the maximum number in this data set, is going to be 8. The median is the number in the middle of when the data is ordered from least to greatest. Obviously, we've done that already. That's why that makes this a little bit easier. If we look for the middle number, that would actually be right here because we have 4 values on one side and 4 values on the other. So the middle of 4 and 5 would be 4.5. For us to find the first quartile, or Q1, we're going to look at the left of the median. So what's the middle of that left-hand side would be right here, and that would be between 2 and 3, which would be 2.5. And then the third quartile, or Q3, is the middle of the right-hand side of the data from the median, and that would be 6.5. So we want to make our box plot. So I'm going to have 1, 2, 3, 4, 5, and 6. So we know, let me make my scale a little smaller so I can fit that 8 in there. 1, 2, 3, 4, 5, 6, 7, and 8. We know that our min and our max are at 1 and 8. Our median is at 4.5. Our Q1 is at 2.5. And our Q3 is at 6.5. So let's draw our box here. Sorry, I'm trying my best. All right, there's my box. Hopefully your box looks a little bit better than mine. And then we want to draw our lines that come from the box that go to the minimum and the maximum, also called, like I said, the whiskers. You may have heard that term before. So that's how you would create a box plot from a set of data. Okay, so let's make some observations from this data. So the lowest 50% of the data value, so our median, breaks this data into 2 parts. So the lower part goes from 1 to 4.5. So that's the smallest number all the way up to the median. The median to the largest number, the maximum, is the highest 50%, and that goes from 4.5 to our maximum, which was 8. The middle 50%, so the box. So how big is the box? The box goes from 2.5 to 6.5. And this actually has a specific name. It's called the interquartile range. I don't know if you've ever heard of that before, but that name refers to the box itself. How big is that box? The first quartile represents the lower 25% of the data, and that is also called the 25th percentile. And what that means is all of the data, or only 25% of the data that's smaller than that value. The third quartile is the first 75% of the data, and that's the 75th percent, saying that all of the data, 75% of the data is below that value. And if you think about the opposite, 75% of the data are bigger than Q1 or that first quartile, and 25% of the data values are above 3, which is the third quartile, not O3, Q3. The median of the lower half is also the quartile 1, which we said was 2.5. And the median of the upper half of the data is the Q3, which we said was, I don't know, my thing is not writing very well today, 6.5. 2.5 and 6.5 would be our Q3, or the median of that right half or the upper half of our data. So now we want to kind of compare two things. So here's our following data set. So data set number 1, and they're already entered from least to greatest, so I don't have to do that part. So the smallest value in data set 1 is 1. The largest value would be the maximum is 23. The middle number here is right in between, let me make sure I counted that right. Yep, right in between 7 and 9, which would be 8. The first quartile is between 3 and 5, which would be 4. And the third quartile is between 11 and 13, which would be 12. So let's do the same for data set 2. And they almost look identical, except the only difference for data set number 2 would be the maximum. The maximum here would be 15 instead of the maximum of data set number 1, which was 23. So we're going to make two different box plots here. So I'm going to count by, let's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I don't have enough to count by 1, so let's count by 2. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And we're going to kind of draw both box plots on the same box or the same number line. So let's do data set 1. So the smallest number here is 1. The first quartile is 4. The median is 8, and I'm just doing my best here. The third quartile is 12, and then we got 23. So we want to draw our box and then draw our lines that come out from our box. That's number 1. And then let's draw number 2 right underneath of it. Everything is the same as the first plot, except for, oh, come on, the maximum, which is 15. Okay, so let's answer some questions about these two box plots. So compare and contrast both box plots. So I'm going to say that they're exactly the same. Except the maximum. So you'll notice that all of the 5 important things in this box plot are the exact same except the maximum. The maximums are different. And the second question is, which box plot is not symmetrical? If we go back and look, box plot number 1 is not symmetrical. And we're going to say that's because the whisker is longer. You'll notice that that right-hand line that comes off the right-hand side of the box is a lot bigger than the other side. So here's an odd number of data values: 3, 7, 10, 15, 18, 21. So they're already in numerical order, least to greatest. That's good. So we can just work off that. The minimum value in the data set is 3. The maximum value of the data set, the biggest number, is 21. The median looks like it is right here, which is 11. And then the first quartile, the middle of this left-hand side, would be 7. And the middle of the right-hand side of the median would be our third quartile, which is 18. So I'm going to again count by twos here. 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. So if I were to create my box plot, I'm going to do all my 5 important lines first. So 3, 7, 11, 18, and then 21. So I make my box and then draw my lines that come off my box. So you'll notice that the median here is closer to the left-hand side of this box than it is to the right-hand side of this box. So that would mean that the data on the right-hand side is a little bit more spread out. Okay, so the time rounded to the nearest hour, 26 tourists spent on excursions at Cat Island, Mississippi on a given day was recorded as follows. So here's the data. Construct a box plot to represent the data. Label the min, max, first quartile, and third quartile. So the minimum is going to be 0. The maximum is going to be 12. So let's see how many data points there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 26. I can read. So 13 and 13 would split it in half. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That'll be there. So 7.5 is going to be our median. So 1, 2, 3, 4, 5, 6, 6 would be our first quartile. 1, 2, 3, 4, 5, 6. This would be our third quartile. So let's make that. So we're going to say 0, 2, 4. Oops, we can count by ones here because it only goes up to 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 0 is going to be important. 6, 7.5, 9, and 12. So let's make our box, draw our lines that come off of our box, or our whiskers. The bottom 25% of tourists spent at most. So our most of our bottom 25% would be 6 hours, and that would be our first quarter. Okay, let's look at one more question. So Mrs. Bridgewater recorded the number of Snapchats 10 different students sent in one day and constructed the box plot below for the data. So we want to use these terms to label the parts of the box plot. So this part on the left, that would be the minimum, and minimum would be our letter F. The left-hand side is our first quartile, and that would be letter B. The line inside the box is the median, letter E. The right-hand side of the box is our third quartile, letter G. And then the right line over here, the biggest value would be our maximum, letter C. So we didn't use average or mean, which is not something we can tell from box plots unless we're given the data. The 50th percentile of the data, so 50 is the middle, the median. In this case, that line is 12. So the middle number of students' number of Snapchats a day would be 12. Let's look at a few more questions on this. Half of the data are between. So let's look at between 2 and 20. That's not half the data, that's all of the data. Between 8 and 12. 8 and 12 is just this side of the box. That's only 25% of the data, or a fourth of the data. Between 8 and 14, that's the box itself, and that is half the data. So I would answer between 8 and 14. And 10 and 12, let's just make sure. Between 10 and 12, we don't really know what part of the data between 10 and 12. It's not part of our 5-number summary. 75% of students send blank or fewer Snapchats. So we're looking for the third quartile. The third quartile, remember we said, was 14. So 75% of students send 14 or fewer Snapchats per day. And the last thing we want to do is add dots to this to complete the dot plot so that it could also represent the data. So we need some more values. We definitely need an 8 because that is the first quartile. And we definitely need a 20, obviously, because that is the third quartile. And let's try that. So 2, 6, 8, 11, 12, 12, 13, 14, 20. If we did, here, let me move that so that we can see what that says. Sorry about that. I'm going to write it here so that we can exactly see it. 2, 6, 8, 11, 12, 12, 13, 14, and 20. That would give me a min and max of 20 and 2, right? Yep. So I need 8 to be I need the median to be 12. 1, 2, 3, 4. So that would be here. But that does not give me a third quartile of 14. It gives me a third quartile of 13 and a half. So I need one more value. I'm going to add another 20. And then that would exactly give me, this is the median now. That would give me 8 as my third quartile and 14 as my, or first quartile and 14 as my third quartile. So that could represent, there could be a million different answers here. That's just 3 dots that I could add to make this dot plot and box plot match each other. All right, let me know if y'all have questions about box plots, and I look forward to hearing from you. Bye, guys.